This is 11.2, sorry, 11, lesson 11, part 2. So A asks us to list the bone density for each woman whose weekly cola consumption was 3. So if we go here, we have one that's here and one that's here. So 3 colas. This is probably maybe 0.868. It's a little below 0.7. Wow, that's really off there, sorry. And then the other would be maybe 0.876. The next one says, list the cola consumption for the women whose bone mineral density was below 0.87. So if we look at 0.87, that's right here, and what's below that? Somebody that drank 3 colas, 7 colas, and 7 colas, and 8 colas. Okay, next one. List the cola consumption for the women whose mineral density was higher than 0.89. So let's put this at 0.89. Oops. So 0.89 would be right here. And I think it said above, so that would be somebody who had no colas and somebody that had 1 cola. So I'm going to go make sure that it said above. Was higher than, yeah. So somebody that had 0 colas and somebody that had 1 cola. So you could, well, this is really what it's asking us. So 0 colas and 1 cola. Number 6, consider x plus y equals 10. How many solutions can you think of? Write all the solutions you can think of in ordered paired form. So we could say 0 plus 10. We could say 1 plus 9. We could say 2 plus 8. We could say 3 plus 7. 4 plus 6. And 5 plus 5. Oops. But couldn't we then let x be 10 and y be 0? So yes, so all of these could be reversed. But if we reverse 5 of 5, we're still going to get 5, 5. So these are all the solutions that will make this equation true. So what does it mean to be a solution to an equation? Anything that you can plug in to balance it on both sides. If we put 0 plus 10, we get 10 equals 10. So anytime you can plug numbers in for the variable and it makes it equal on both sides, that would be a solution. So number 7, is -1 for a solution to this equation? So x is -1, y is 4. So we're going to come over here and we're going to put x plus y equals 3. X is -1, y is 4. So now let's do the math. 3 equals 3. So that balances. So yes, it is a solution. List two ordered pairs that are solutions to the equation x plus y equals 3. So 1, 2, because 1 plus 2 equals 3, and 0, 3. List two other ordered pairs that are solutions. So those are solutions other than -1, 4. Fill in the ordered pairs so that they are solutions to the equation. So if I let x be 0, we'll put a 0 in place of x, and everything else stays the same. So I'm going to put a 0 here, and 0 plus anything just goes away. So we get 2y equals 10. Divide by 2, divide by 2. Or you can think to yourself, what times 2 equals 10? 5. Whoops. If this was 1, we have x plus 2 times 1, which is 2. X plus 2, what plus 2 equals 10? 8. If you have questions, write them down, and we will get to them during class. It says find 5 solutions to the equation y equals 2x minus 1. First, pick values for x. Which is the domain. Next, plug in to equation to find y. So plugging it in, so we need to pick our values for x. It's always good to pick 2 negatives, 0, and 2 positives. And it doesn't matter which numbers you pick. But you don't want to pick x equals 15 because then you're going to have to make a graph that goes all the way out to 15. But if you wanted to, you could. So that means we've got to take -2 and put it in place of x. So y equals 2 times -2 minus 1, which is -4 minus 1, which is -5. So when x is -2, y is -5. Now we're going to go and we're going to put -1 in place of x. So 2, -1 minus 1, which is -2 minus 1, which is -3. 2 times 0 minus 1. 0 minus 1 is -1. So 2 times 1 is 2, minus 1 is 1. So I'm going to write that down. 2 times 1 minus 1, I'm getting it from right here, y equals 2 minus 1, which is 1. So that becomes 1. And then one more, if we were to make this a 2, 2 times 2 is 4, and 4 minus 1 is 3. How do these ordered pairs help us know anything about the graph? We can see what shape they make. -2, -5 would be here. -1, -3. 0, -1. 1, 1. 2, 3. Oops. 1, 1 would be right here. This is not right. Alright, so how do these, we can see what shape it makes, and we can see that it's making a line. Not the best line in the world, but a line nonetheless. And do you see that this is a point on that line and it was a solution? If we could take the point, if we could see exactly what this point was, and we plugged it into our equation, just like we did here, every point that's on this line would become a solution. How many solutions exist to this equation? If every point is a solution, then it would have an infinite number of solutions. Meaning it never stops. There's that many. And where are they located? On the line. Number 11. I believe I'll stop this video and start a new one, part 3.